In this example, we'll be going through the procedure of how to graph a quadratic function given in factored form. Now, to accurately sketch the graph of this function, I'm going to need several points. The points I'm going to need are the x-intercepts. I'm also going to need the y-intercept. And I'd also like to have the vertex. If I have those points, I'll have everything I need to sketch the graph of this function. Now, to find the x-intercepts, it's important to know what an x-intercept is. An x-intercept is a point anywhere along the x-axis where a parabola intersects, which also means that the y-coordinate at any of these points will be 0. So if I can set the y-coordinate equal to 0, or the y value equal to 0, I should be able to find my x-coordinates. So for my x-intercepts, I'm going to say that replace y with 0 and say x minus 2, x minus 6 is equal to 0. Now recall using the zero product property that if either set of brackets here is equal to 0, then the whole function will be. So then that leads to x being equal to 2 or x being equal to 6, because 2 minus 2 would be 0, or 6 minus 6 would be 0, which gives me 2 points of 2 and 0, and another point here of 6 and 0. Now if I want to find the y-intercept, I can use a similar strategy. Anywhere along the y-axis, the x-coordinate will be 0. So I can replace x with 0 in the function given in the problem. So if I replace x with 0, they're just going to drop out of the expression. So I've got negative 2 times negative 6, which gives me a value of positive 12. So my y-intercept then is located at a value of x being 0 and y being positive 12. As discussed earlier, if I have both points for my x-intercepts, I know that halfway between those points, I will find my axis of symmetry. So I'm going to sketch in my axis of symmetry now, as it will help me sketch the graph more accurately now in a minute. So there's my axis of symmetry. So I know my vertex will lie along here. Now, the x-coordinate of my vertex should be halfway between positive 2 and positive 6. So I can add those, average them, get a value of 4. And taking that same value of 4 and replacing it in the original function given, I get a y-coordinate of negative 4. So now the vertex is located at 4 and negative 4. I've got my y-intercept. I've got everything I need to graph this function. So I've got a point at 4, negative 4. I graphed my intercepts previously. I've got a y-intercept here. Using my axis of symmetry, I'm 1, 2, 3, 4 points away. Following that same line, I'll go 4 points away on the other side. And that gives me some points that I can join up to produce the graph of my parabola.